Let's now start this lesson by defining what data visualization is. Data visualization is the technique to present the data in a pictorial or graphical format. It enables stakeholders and decision makers to analyze data visually. The data in graphical format allows them to identify new trends and patterns easily. Well, you might think, why data visualization is important? Let's explain with an example. You are a sales manager in a leading global organization. The organization plans to study the sales details of each product across all regions and countries. This is to identify the product which has the highest sales in a particular region and up the production. This research will enable the organization to increase the manufacturing of that product in the particular region. The data involved for this research might be huge and complex. The research on this large numeric data is difficult and time-consuming when it is performed manually. When this numeric data is plotted on a graph or converted to charts, it's easy to identify the patterns and predict the result accurately. The main benefits of data visualization are as follows. It simplifies the complex quantitative information. It helps analyze and explore big data easily. It identifies the areas that need attention or improvement. It identifies the relationship between data points and variables. It explores new patterns and reveals hidden patterns in the data. There are three major considerations for data visualization. They are clarity, accuracy, and efficiency. First, ensure the data set is complete and relevant. This enables the data scientist to use the new patterns yield from the data in the relevant places. Second, ensure using appropriate graphical representation to convey the right message. Third, use efficient visualization technique, which highlights all the data points. There are some basic factors that one would need to be aware of before visualizing the data. Visual effect, coordination system, data types and scale, informative interpretation. Visual effect includes the usage of appropriate shapes, colors, and size to represent the analyzed data. The coordinate system helps to organize the data points within the provided coordinates. The data types and scale choose the type of data, such as numeric or categorical. The informative interpretation helps create visuals in an effective and easily interpretable manner using labels, title, legends, and pointers. So far, you have learned what data visualization is and how it helps interpret results with large and complex data. With the help of the Python programming language, you can perform this data visualization. You'll learn more about how to visualize data using the Python programming language in the subsequent screens. Many new Python data visualization libraries are introduced recently, such as MatPlotLib, Visp, Bokeh, Seaborn, Pygel, Folium, and Networks. The MatPlotLib has emerged as the main data visualization library. Let's now learn about this MatPlotLib in detail. MatPlotLib is a Python two-dimensional plotting library for data visualization and creating interactive graphics or plots. Using Python's MatPlotLib, the data visualization of large and complex data becomes easy. There are several advantages of using MatPlotLib to visualize data. They are as follows. It's a multi-platform data visualization tool built on the NumPy and SciPy framework. Therefore, it's fast and efficient. It possesses the ability to work well with many operating systems and graphic backends. It possesses high-quality graphics and plots to print and view for a range of graphs, such as histograms, bar charts, pie charts, scatter plots, and heat maps. With Jupyter Notebook integration, the developers have been freed to spend their time implementing features rather than struggling with cross-platform compatibility. It has large community support and cross-platform support as it is an open-source tool. It has full control over graph or plot styles, such as line properties, fonts, and axis properties. Let's now try to understand a plot. A plot is a graphical representation of data, which shows relationship between two variables or the distribution of data. Look at the example shown on the screen. This is a two-dimensional line plot of the random numbers on the y-axis and the range on the x-axis. The background of the plot is called grid. The text first plot denotes the title of the plot, and text line 1 denotes the legend. You can create a plot using 4 simple steps. Import the required libraries, define or import the required dataset, set the plot parameters, display the created plot. Let's consider the same example plot used earlier. Follow the steps below to obtain this plot. The first step is to import the required libraries. Here we have imported NumPy and pyplot and style from MatPlotLib. NumPy is used to generate the random numbers, and pyplot, which is built in Python library, is used to plot numbers, and style class is used for setting the grid style. MatPlotLib inline is required to display the plot within Jupyter Notebook. The second step is to define or import the required dataset. Here we have defined the dataset random number using NumPy random method. Note that the range is 10. We have used the print method to view the created random numbers. The third step is to set the plot parameters. In this step, we set the style of the plot, labels of the coordinates, title of the plot, the legend, and the line width. In this example, we have used ggplot as the plot style. The plot method is used to plot the graph against the random numbers. In the plot method, the word G denotes the plot line color as green. Label denotes the legend label, and it's named as line 1. Also, the line width is set to 2. Note that we have labeled the x-axis as range and the y-axis as labels, and set the title as first plot. The last step is to display the created plot. Use the legend method to plot the graph based on the set conditions, and the show method to display the created plot. Let's now learn how to create a two-dimensional plot. Consider the following example. A Nutri worldwide firm wants to know how many people visit its website at a particular time. This analysis helps it control and monitor the website traffic. This example involves 2 variables, namely users and time. Therefore, this is a two-dimensional or 2D plot. Take a look at the program that creates a 2D plot. Object Web Customers is a list on the number of users, and time hours indicates the time. From this, we understand that there are 123 customers on the website at 7 a.m., 645 customers on the website at 8 a.m., and so on. The ggplot is used to set the grid style, and the plot method is used to plot the website customers against time. Don't forget to MatPlotLib inline to display or view the plot on the Jupyter Notebook. The website traffic curve is plotted, and the graph is shown on the screen. It's also possible to change the line style of the plot. To change the line style of the plot, use define the line style as dashed in the plot method. Observe the output graph changes to a dashed line. Also note that the color is defined as blue. Using MatPlotLib, it's also possible to set the desired axis to interpret the required result. Use the axis method to set the axis. In this example shown on the screen, the x-axis is set to range from 6.5 to 17.5, and the y-axis is set to range from 50 to 2000. Let's now understand how to set the transparency level of the line and to annotate a plot. Alpha is an attribute which controls the transparency of the line. Lower the alpha value, more transparent the line. Here, the alpha value is defined as 0.4. The annotate method is used to annotate the graph. The syntax for annotate method is shown on the screen. The keyword max is the attribute that denotes the annotation text. HA indicates the horizontal alignment. VA indicates the vertical alignment. XY text indicates the text position, and XY indicates the arrow position. The keyword arrow props indicates the properties of the arrow. In this example, the arrow property is defined as the green color. The output graph is shown on the screen. So far, you've learned how to set line width, title, x-axis and y-axis label, title of the plot, legend, line color, and annotate the graph for a single plot. The plot we created for website traffic in the previous screens is for only 1 day. Let's now learn how to create multiple plots, say for 3 days, using the same example. The dataset number of user for Monday, Tuesday, and Wednesday is defined with respect to its time distribution. Use different color and line width for each day to distinguish the plot. In this example, we have used red for Monday, green for Tuesday, and blue for Wednesday. The output graph is shown on the screen. A subplot is used to display multiple plots in the same window. With a subplot, you can arrange plots in a regular grid. All you need to do is specify the number of rows, columns, and plot. The syntax for a subplot is shown on the screen. It divides the current window into an M by N grid and creates an axis for a subplot in the position specified by P. For example, subplot 2, 1, 2 creates 2 subplots, which are stacked vertically on a grid. If you want to plot 4 graphs in one window, then the syntax used should be subplot 2, 1, 4. Layout and spacing adjustment are 2 important factors to be considered while creating subplots. Use PLT subplots adjust method with the parameters hspace and wspace to adjust the distances between the subplot and move them around on the grid. In this demo, you can see how to create 2 subplots that will display side by side in a single frame. 2 subplots stacked one on top of the other or vertically split in a single frame, and 4 subplots displayed in a single frame. First, import MatPlotLib pyplot and style. Type %matplotlib in line to view the plot in Jupyter Notebook. Define the parameters such as temperature, wind, humidity, precipitation data, and time data. You can see the data being typed here. Next, to create 2 subplots to be displayed side by side in a given frame for 1, 2, 1 and 1, 2, 2, specify the figure size, subplot space, title, the color for time and temperature data, which is blue here, and line style and width. Similarly, specify the color for wind, which is red, its line style, and width. You can see the temperature and wind subplot charts displayed side by side in a given frame here. To create subplots for 2, 1, 1 and 2, 1, 2, specify the parameters. This will create 2 subplots stacked one on top of the other or vertically split in a given frame. Let's use humidity and precipitation data to plot the graphs. Specify the title, color, line style, and line width for both the graphs. You can see the two subplots stacked one on top of the other with two different colors, indicating precipitation and humidity. Here, the two graphs are separate. Finally, let's draw four subplots for 2, 2, 1, 2, 2, 2, 2, 2, 3, and 2, 2, 4 that will display in a given frame. Specify the title, subplot data, color, line style, and line width for all four subplots. You can see the four subplots displayed in a single frame. In this demo, you learned how to create subplots displayed side by side, vertically split subplots, and four subplots displayed in a single frame using MatPlotLib. You can create different types of plots using MatPlot library: histogram, scatterplot, heat map, eye chart, error bar. Histograms. Histograms are graphical representations of a probability distribution. In fact, a histogram is a kind of bar chart. Using MatPlot library and its bar chart function, you can create histogram charts. A histogram chart has several advantages. Some of them are as follows. It displays the number of values within a specified interval. It's suitable for large datasets as they can be grouped within the intervals. Scatterplots. A scatterplot is used to graphically display the relationship between variables. A basic plot can be created using the plot method. However, if you need more control of a plot, it's recommended that you use the scatter method provided by MatPlot library. It has several advantages. It shows the correlation between variables. It's suitable for large datasets. It's easy to find clusters. It's possible to represent each piece of data as a point on the plot. In this demo, you'll learn how to generate a histogram and scatterplot using MatPlotLib. Let's import a dataset called Boston Dataset, which we will use to create the histogram and scatterplot from the Simplilearn library. Let's import MatPlotLib PyPlot. Type %matplotlib in line to view the plot in Jupyter Notebook. Let's use the data in Boston Real Estate Dataset to create the histogram and scatterplot. Load this data. You can view this data by using the print command. Now define the x-axis for the data, which is Boston Real Estate data. Likewise, define the y-axis for the data, which is Boston Real Estate data with the target extension. Specify the plot style, figure style, number of bins, and labels of the x-axis and y-axis. Use the Show method to display the histogram created by you. Specify the style, size, datasets, and labels of the scatter plot that you want to create. Use the Show method to display the scatter plot created by you. Heat maps. A heat map is a better way to visualize two-dimensional data. Using heat maps, you can gain deeper and quicker insight into data than those afforded by other types of plots. It has several advantages. It draws attention to the risky-prone area. It uses the entire dataset to draw bigger and more meaningful insights. It's used for cluster analysis and can deal with large datasets. In this demonstration, you'll learn how to generate a heat map for a dataset using MatPlotLib. Let's import the required libraries, MatPlotLib, PyPlot, and Seaborn. Type %matplotlib inline to view the plot in Jupyter Notebook. Let's load the flights dataset from the built-in datasets of Seaborn library. Use Head to view the top 5 records of the dataset. We have to arrange the columns to generate the heat map. Let's use the pivot method to arrange the columns, month, year, and passengers. Let's view the flight dataset that's now ready to generate the heat map. Let's use the heat map method and pass flight data as an argument. This will generate the heat map, which you can see here. In this demo, you learned how to create and display a heat map. Pie charts. Pie charts are typically used to show percentage or proportional data. Note that usually the percentage represented by each category is provided next to the corresponding slice of the pie. MatPlot library provides the pie method to make pie charts. It has several advantages. It summarizes a large data set in visual form. It displays the relative proportions of multiple classes of data. The size of the circle is made proportional to the total quantity. In this demonstration, you'll learn how to create a pie chart and display it. First, import MatPlotLib PyPlot. Type %matplotlib inline to view the plot in Jupyter Notebook. Type the job data within parentheses using single quotes separated by commas. Specify the labels as IT, Finance, Marketing, Admin, HR, and Operations. Specify the slice IT to explode. Use the show method to display the pie chart. You can see the pie chart with the slices, labels, and IT, the largest slice. Error bars. An error bar is used to show the graphical representation of the variability of data. It's used mainly to point out errors. It builds confidence about the data analysis by unleashing the statistical differences between the two groups of data. It has several advantages. It shows the variability in data and indicates the errors. It depicts the precision in the data analysis. It demonstrates how well a function and model are used in the data analysis. It defines the underlying data. Seaborn is a Python visualization library based on MatPlotLib. It provides a high-level interface for drawing attractive statistical graphics. It was originally developed at Stanford University and is widely used for plotting and visualizing data. There are several advantages. It possesses built-in themes for better visualizations. It has tools built-in statistical functions which reveal hidden patterns in the dataset. It has functions to visualize matrices of data which become very important when visualizing large datasets.
Hey, want to become an expert in big data? Then subscribe to the Simplilearn channel and click here to watch more such videos. To nerd up and get certified in big data, click here.